So let's take another look at another example here. I want to determine all intervals of concavity for this thing, this particular function, and I want to identify all the inflection points. So the first thing obviously I need to do is take a look at f prime of x. The first derivative will be 9x squared minus 2x, which is equal to x times 9x minus 2. That, in this form, I can quickly and easily read off the fact that the critical values are going to be x equals 0 and x equals 2/9. So there's my two critical values. The second derivative will be 18x minus 2. That, if I set it equal to 0, that implies that 2/18, which is equal to 1/9, is a candidate for an inflection point. Okay, so what I need to do is I'm going to take a look at f double prime of x and how it relates to 1/9. So I need a value less than 1/9. How about 0? Well, f double prime of 0 is going to be a negative number. So how about a value bigger than 1/9? Well, how about 1? So at 1, I have a positive value for f double prime. Now, what that just did for me, sorry, I just realized I'm writing a bit of a slant here. What that just did for me is a bunch of things. Number one, I now know that f of x has an inflection point at x equals 1/9. I also know that f of x is concave down. I'm sorry, concave up. Let's do concave up first. Actually, I probably should just go left to right and stay with down. Concave down. Sorry about that. On negative infinity to 1/9. And I know that it's concave up on 1/9 to infinity. Now, I also want to identify, this is inflection points and concavity, but you know what? While we're here, I have these critical values. What I really should be doing is trying to determine if those critical values are local mins or maxes or not. So what is the second derivative at 0? Well, all I got to do is look down this chart. 0 is less than 1/9, and I actually use 0 to evaluate it. It's the second derivative is going to be negative. Well, if the second derivative is negative, that tells me 0 is a local max. And then 2/9, 2/9 is in this group right here, because this goes from 1/9 to infinity. So 2/9 is in this interval. Well, that's positive. So if it's positive, then I know I have a local min at x equals 2/9. And I change the inflection point at 1/9. So let's go ahead and jump into Maple and take a look at it and see what we get. Okay, so here it is in Maple. I'm seeing I'm concave down, just like I said I was. 1/9 is like right in here someplace, because this is a half. So I'm concave now down. There's a change of inflection here. Then I go concave up. I have a local max right here and the local min right here, which match up with what we saw when we did the analysis on it.